The following content is provided under WISA mechanism group.
Today we'll talk about the formation of imines in organic chemistry, and for the formation of imines we need to know what reagents we need, and secondly we need to know the reaction conditions. In this case, to form an imine we'll need an aldehyde or a ketone, any of the two will do. We'll also need a primary amine, and we'll need catalytic acid to provide the acidic conditions for a reaction to take place. So in this kind of reaction, this gives you the general scheme of the reaction, and we are seeing an aldehyde reacting with a primary imine. It has to be a primary imine in catalytic acidic conditions to give us an imine plus water being the byproduct. So we're not interested in the byproducts. All we want is the main product, which is our imine. So one of the ways of increasing our products is basically by removing the water to force the reaction to move towards the right hand side or towards the product side. And with the imine, we're basically replacing the oxygen on the aldehyde or ketone with the nitrogen of the primary amine that was used. And then the two hydrogens on the primary amine together with oxygen will combine to give us water, whereas the alkyl group that was attached to the primary amine will remain with the nitrogen as it binds to a carbon to form the imine. I will look at an example of the formation of imines. An aldehyde, this is known as the benzene carb aldehyde. The benzene carb aldehyde. It will react with the primary amine, in the presence of catalytic acid to give us the desired imine, which is our main product. You may want to add on water as the byproduct, but we're not interested in the water. All we're interested in is the main product being the imine. So having looked at this example, we know that the oxygen is being replaced by the nitrogen, and the double bond is just left the way it is. We're just replacing this oxygen with this nitrogen. So we're looking at this carbon here. This carbon is the same as this carbon there. The only thing we have changed is removing this oxygen and replacing it with the nitrogen of the double bond. So that's what we're having here. These two are basically the same carbons. We're not changing anything but removing the oxygen and replacing it with the nitrogen, then getting rid of the hydrogens. The two hydrogens on the primary amine, we get rid of that, and we're just left with the nitrogen together with the alkyl group, or whatever group that is attached to the nitrogen in order to form the imine. Next, we're going to look at the reaction mechanism to see how this reaction actually takes place. So we looked at the formation of imines from aldehydes and ketones. We want to look at the mechanism by which that formation occurs. And we are having our starting ketone. The R group could be an alkyl group, or it could be hydrogen group. So this could be a ketone or an aldehyde. So we're looking at the general reaction mechanism. So remember we said we need catalytic acidic conditions. So in the presence of a catalytic acid, which is represented by the proton, we'll see that the lone pairs on the oxygen atom go ahead to attack that proton. And this will lead to the formation of this group with a plus charge on the oxygen. Then once this is done, once the proton has been attacked, next we are going to react with the amine, the primary amine that was used, and that is the nitrogen bonded to the R group, R prime. Then we have the two hydrogens, but then we have lone pairs on the nitrogen. So these lone pairs are going to attack the carbon that's bound to the oxygen, because that carbon is partially positive due to the electronegativity of the oxygen. So these lone pairs will come and bind this carbon. Binding of the lone pairs to this carbon will create 5 bonds on this carbon. So remember, carbon cannot have a maximum of only 4 bonds. So it has to lose one of the 2 bonds with oxygen. So that bond is lost to oxygen, and this helps in the formation of this next structure, which is R, R, OH, nitrogen. This is the R prime. This is hydrogen, hydrogen. This becomes plus. The nitrogen gains the plus charge. We want to ensure that this plus charge is now neutral to stabilize this compound, so we have to lose one of the hydrogens. So minus one of the protons. This will give us this other structure. R, R, OH, nitrogen, R prime, H. So, so basically we have R, R, OH, R prime, and then H. But then remember, we have lone pairs now on the hydrogen, because this hydrogen that was lost gave the 2 lone pairs in the bond back to nitrogen to make it a neutral species, a neutral element. So now at this point, these lone pairs are going to attack that carbon. But before that happens, we need to ensure that this group, the OH group, is susceptible and easy to break off. How does that happen? It has to react with another proton. So we have another proton coming in from the catalytic acid, and one of the lone pairs and oxygen will bind to that proton, and this will give us R, R, OH2 plus, together with our nitrogen, R prime, hydrogen, lone pairs. So now this group can easily be lost. So now at this point, we have these lone pairs binding to that carbon, and by binding to that carbon, this bond is broken off to lose the water. So this step we're losing water to form R, R, double bonds, nitrogen, R prime, and hydrogen. That becomes positively charged once more. Now that we have a positively charged nitrogen atom, we want it to be neutral. How are we going to do that? By basically losing this hydrogen. So this hydrogen will be lost, and those bonds will go back to nitrogen. Lose hydrogen, and this will give us R, R, double bond, and R prime. This is our imine. So we realize the steps are basically repeated, and they're quite simple, quite direct. And basically right from the beginning of the aldehydes to the formation of our desired product, which is the imine, we have a total of about 7 steps. So that is practically how we're able to form the imines from the aldehydes and ketones.